All right, so get this. We're talking limitless energy a day.
Limitless energy.
And no, this isn't sci-fi, okay?
Right.
Scientists at Ohio State University are looking at using nuclear waste to power batteries.
Wow.
I know, it's pretty wild. We're diving into this article from scitechdaily.com all about it.
Yeah, I saw that one.
It's kind of a head-scratcher at first, right?
It is.
Nuclear power is already kind of controversial, right?
Yeah.
Some people think it's super dangerous. Some people think it's the answer to all of our energy needs.
Yeah.
Yeah.
Could this be the bridge between those two?
Yeah, exactly. Could this battery bridge that gap?
Yeah.
So how does this thing even work?
Okay, so imagine tiny crystals.
Okay.
They're called scintillators. And when a radiation hits them, they emit light.
Like a glow stick.
Yeah, exactly like a glow stick. But instead of you cracking it, it's radiation.
Wow.
Now, attached to these crystals are solar cells,
Okay.
the same kind that are used for solar panels.
Gotcha.
These cells capture the light that's emitted by the scintillators and convert it into electricity.
All right.
It's a two-step process.
Okay.
Radiation triggers light, and light is transformed into usable electricity.
So like a little nuclear-powered firefly?
Yeah.
And they actually built this thing?
They did.
Oh.
The prototype is tiny, like only about 4 cubic centimeters.
4 cubic centimeters, is that
Like the size of a dice.
Oh, wow. Okay.
But even at that scale, they've been able to generate electricity using cesium-137 and cobalt-60.
And those are...
Common radioactive isotopes found in nuclear waste.
Okay, so it actually works.
It does.
How much power are we talking, though? Can I run my toaster off of this?
Not quite.
Okay.
The power output so far is pretty small.
Okay.
With cesium-137, they measured 288 nanowatts.
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 Is that a lot?
So to give you some perspective, a typical phone charger uses about 5 watts,
Okay.
which is billions of times greater.
Okay, so not powering my house just yet.
Not yet, but
But I'm sensing there's more to this story.
yeah. So they also tested the battery with cobalt-60,
Okay.
which emits a more powerful form of radiation.
Uh-huh.
And with cobalt-60, they got a significantly higher output,
How much higher?
1.5 microwatts.
Okay, so still small, but
Still tiny, but it's a jump.
it's a big jump.
Okay, and it shows that the type of radiation matters.
Exactly.
Okay, so this is like turning trash into treasure, right?
Right.
We think of nuclear waste as a hazard,
Yeah.
but this research is saying, hey, maybe it's actually a valuable resource.
Yeah, and they say that the shape and size of these crystals
Uh-huh.
play a key role in how much power the battery can generate.
Oh, okay, interesting.
The larger crystals
Yeah,
can absorb more radiation.
meaning more light, meaning more electricity.
Exactly. And a larger surface area on the solar cell
Mm-hmm.
that increases the power generation as well.
So it's not just about finding the right nuclear material, it's about building the battery the right way.
Exactly.
So even if they can scale this thing up, where would we even use it? That's where it gets really interesting.
Okay.
So you're probably not going to be powering your phone with this anytime soon.
Okay.
But imagine like environments where reliable, long-lasting power is crucial.
Okay.
And getting to those places is really difficult.
Okay, I'm thinking like outer space.
Or the deep sea.
Oh, that's cool.
Yeah,
Okay, so space probes, deep sea robots.
exactly.
Cool, but maybe a little far out there for most of us.
What about the most obvious application?
Right.
Managing the nuclear waste itself.
Whoa, okay, hold on.
Yeah.
Before we go full sci-fi here, what about safety?
Yeah.
Nuclear anything kind of makes people nervous.
Understandably so.
Are these batteries safe to handle?
So these batteries don't actually contain any loose radioactive material.
Oh,
They're safe to touch.
oh, wow.
Think of it like a solar panel.
Okay.
It harnesses existing sunlight. It doesn't create more sun.
Gotcha.
These batteries would be deployed in environments where radiation is already present, like a nuclear waste storage facility.
Okay.
They utilize the existing radiation. They don't introduce more.
So they're tapping into a power source that's already there.
Exactly.
Okay, that makes sense.
Yeah.
But those facilities are still heavily regulated for a reason. These batteries would have to be incredibly reliable.
Yeah.
What about long-term effects?
So, yeah, you're hitting on some key limitations here.
Okay.
This technology is still very much in its early stages.
Okay.
Durability is a big question mark.
Yeah.
How long can these batteries actually function
Right.
in these really harsh environments?
Yeah.
And scaling up production to make it cost-effective is another hurdle.
Yeah, that makes sense. We wouldn't expect them to roll this out tomorrow, right?
Right.
It's going to take time, research,
Yep.
and probably a lot of money.
Definitely.
But the potential is definitely there.
Absolutely.
So what are the scientists saying about next steps?
They're really focusing on optimizing the design of the battery. Yeah. So remember how we talked about the size of the crystals and the solar cell surface?
Yeah.
They're experimenting with different configurations to see how they can maximize energy conversion.
Interesting.
And they're also trying to figure out which types of nuclear waste work best.
Okay.
It's a multifaceted challenge.
Yeah.
But the initial results are really promising.
It's like they're cracking a code.
Yeah.
They're figuring out how to use a power source that's been right there this whole time.
It's true.
So where does this leave us? What's the takeaway for the average person listening to this for the first time?
I think the biggest takeaway is that we might need to rethink how we see nuclear waste.
Okay.
Instead of thinking of it as just a burden, something to bury and forget about.
Yeah.
What if we thought of it as a resource?
Okay.
A solution just waiting to be unlocked.
I like that.
This is just one example of how thinking differently can turn a challenge into an opportunity.
It really makes you think, what other waste products could we use if we just approached the problem differently?
Exactly. And it shows how different fields are all connected.
Yeah.
This isn't just about nuclear physics.
Right.
This is about energy, the environment, even space exploration.
Yeah, it's about thinking outside the box.
Right. Exactly.
I'm already thinking about how this could change things.
Yeah.
So we've talked about how this nuclear-powered battery works. We've talked about what we could use it for.
Yep.
And some of the challenges. But there's another layer to this I think we should explore.
Okay.
The societal impact.
Oh, yeah.
How might this change how people see nuclear power in general?
That's a great question.
I mean, it's been controversial for decades.
For sure.
There are valid concerns about safety
Yeah.
and waste disposal.
Absolutely.
This battery could change that conversation.
That really could.
If we can show that we can use the waste safely and effectively, it might just ease some of those worries. It could even open up new ways to develop nuclear energy, focusing on safer, more sustainable approaches.
Definitely.
So this tiny battery might not just power some deep-sea robots.
Right.
It might actually change how we think about energy as a whole.
It's an exciting thought, isn't it?
It is. Okay, so we've covered a lot of ground in this first part of our deep dive.
Look, yeah.
What else is there to explore in part 2?
Well, we've talked about some potential applications, but let's get specific.
Okay.
What are the real-world scenarios where we could actually use this in the near future?
Okay.
And what about the economics of it all?
Yeah.
Could this lead to new industries?
Oh, wow.
Or even disrupt existing ones?
Ooh, those are great questions. We'll be right back after a short break to unpack all of that and more. So we're back and still thinking about this nuclear-powered battery.
Yeah, it's pretty wild.
It really is tiny, but potentially world-changing. Raises a ton of questions, too.
Yeah, for sure.
Before the break, we were talking about some interesting scenarios, like where could we actually see this being used?
Right, like in the real world.
Yeah, like soon.
Well, those extreme environments, we talked about space and the deep sea.
Yeah.
There are already companies and research institutions working in those areas.
Right.
And they're always facing power challenges.
I can imagine.
Imagine like a deep-sea probe mapping the ocean floor.
Okay.
Powered by a battery that could last for decades.
Wow.
Fueled by the radioactive elements that are already in the seabed.
That would be incredible.
Or a Mars rover.
Okay.
Venturing further than ever before. Not limited by solar power.
Because it's got this battery.
Exactly. A battery that thrives in the Martian environment.
So this isn't just sci-fi anymore.
No, it's becoming a real possibility.
Wow. So what about closer to home? You mentioned economic implications.
Yeah.
How could this disrupt the industries we see every day?
Think about infrastructure.
Okay.
Bridges, pipelines, tunnels.
Okay, yeah.
Those are critical structures. And they require constant monitoring for safety and maintenance.
Right.
But it can be really difficult to access those.
Yeah, expensive, dangerous.
Exactly.
So these sensors.
Sensors powered by these long-lasting batteries could provide continuous data.
Oh, that's a good idea.
Alerting people to problems before they become huge issues.
So we could prevent disasters.
Potentially, yeah.
And save money.
And save lives.
Okay, so reliability and longevity are key here.
Yeah, for sure.
But wouldn't there be pushback from companies that make money from the way things are now?
Of course.
Like battery manufacturers?
Right, but disruption can lead to innovation.
True.
So, yeah, some industries might see this as a threat, but others will see it as a huge opportunity.
Okay, so who are the winners in this?
Well, imagine companies that specialize in these nuclear-powered sensor networks.
Okay.
Or companies that develop new materials, new manufacturing techniques to scale up production.
So it's not just about replacing batteries.
Right.
It's about creating a whole new industry.
Exactly.
But let's be realistic. Not every new technology becomes super popular.
That's true.
What are some of the roadblocks here?
Well, cost is a big one.
Yeah.
Right now, these batteries are expensive to make, especially at such a small scale.
Right.
Bringing that cost down will be essential.
Okay, and what about public perception?
Yeah, we talked about how this tech could change how people view nuclear power.
Yeah.
But some people will always be afraid of anything nuclear.
That's true.
No matter how safe it is.
So how do you get over that fear?
Transparency education and a really strong track record of safety.
You can't just say, trust us, it's safe.
No, you have to show people how it works.
And what safety measures are in place.
Exactly.
Okay, so beyond cost and fear, are there ethical concerns?
Oh, yeah, absolutely.
Like what?
Access and equity.
What do you mean by that?
Who benefits from this technology?
Okay.
Will it be available to everyone?
Or just rich countries?
Exactly. Those are questions scientists and policymakers need to think about.
So it's not just about the science,
Right.
It's about the impact on society.
Absolutely.
This battery is small,
Tiny.
but it could affect so many parts of our lives.
It really highlights how everything is connected.
It does.
A scientific discovery in one area
Yeah.
can affect the global economy,
Wow.
international relations,
Yeah.
even how we see ourselves in the universe.
Okay. That's a lot to think about.
It is, but it's exciting too.
It is. We started talking about limitless energy, and now we're seeing what that future might actually look like.
It's pretty cool.
So where do we go from here? What else can we learn from this research?
Well, we've talked a lot about the good stuff,
Yeah.
but this is still a new technology.
Yeah.
There's a lot we don't know.
Like what?
What happens to these batteries when they die?
Oh, that's a good question.
How do we make sure the nuclear materials are sourced responsibly?
So we need to be careful.
Yes, definitely.
We need to be excited, but also think critically.
Exactly.
This could be revolutionary.
It could.
But we have to understand both the good and the bad.
I agree scientific progress isn't always a straight line.
Yeah.
There will be setbacks,
Ah.
unexpected consequences.
All right.
And there's always more to learn.
Always more to learn. This has been such an interesting conversation.
Yes.
So many twists and turns.
We went from a tiny battery
I know, right?
to space exploration,
Yeah.
the future of energy.
And even ethical questions.
It's been great exploring all these ideas with you.
Likewise. And it shows how important it is to be curious.
Yeah.
And to look at things from different angles.
Absolutely.
It makes me wonder
What?
other amazing discoveries are out there.
Oh, yeah.
Just waiting to be found.
That's the beauty of science, isn't it?
It is.
It's a never-ending quest for knowledge,
Yeah.
driven by our curiosity.
And who knows what incredible breakthroughs are just around the corner.
I can't wait to find out.
It really is amazing to think about, isn't it?
It is.
This tiny battery
Yeah.
powered by something we thought was a problem
Right.
could be the answer to so many others.
Mm-hmm.
It makes you wonder what other impossible ideas are out there.
Yeah, what other aha moments haven't we had yet?
Exactly.
I think it shows how amazing people are, you know?
Yeah.
We love to explore and innovate,
We do, even when things seem impossible.
especially when things seem impossible. And this battery,
Yeah.
it could change everything.
Energy exploration, even how we think about waste.
It shows you the future is full of possibilities.
Yeah. I think what really struck me
What's that?
is that this isn't just a new technology.
Okay.
It's a new way of thinking.
Yeah, it makes you rethink what's possible.
What is waste, really?
Yeah, and where do solutions come from?
We get stuck in our ways of thinking.
We do. We focus on just getting rid of the waste.
Yeah, just bury it. Forget about it.
This battery says, wait a minute.
Maybe the waste is just the beginning. One person's trash is another person's treasure.
Right, but this is more than that.
Yeah.
It's not just finding a new use for something old.
It's like turning something bad into something good.
Exactly.
You have to recognize that things have value even if we don't see it at first.
And we need to be creative and scientific to unlock that value.
And we talked about the challenges, right?
Yeah.
The ethical questions, the need to be careful and open about everything.
Of course, innovation should be exciting, but we can't forget to think critically.
We need to ask the tough questions.
What are the risks? What are the consequences? Who benefits?
Exactly.
It's a balancing act for sure.
Yeah, embracing the potential, but understanding it's complicated.
It's what makes this so interesting to talk about.
It's not just about the battery itself.
It's about the bigger picture.
It's about the future and how we think about solving problems.
It's a future I'm excited to be a part of.
Me too.
Yeah.
So to wrap things up,
Yeah.
We've learned that scientists have figured out how to use nuclear waste to make electricity.
Which is amazing.
I know, right? Something we thought was a problem.
Could actually be a solution.
Yeah, it could change how we think about energy exploration and waste itself.
It's early days, but the potential is huge.
And this battery is a symbol of what people can do.
Yeah, our ingenuity.
Finding solutions in the most unexpected places.
It's about turning problems into possibilities.
Seeing value where others see waste.
And pushing the boundaries of what we think is possible.
It makes you wonder what other world-changing innovations are out there waiting for us.
That's the best part, isn't it?
It is. Thanks for joining us on this deep dive.